Good morning. I want to talk to you today about using algebraic expressions in a geometric context, and I'm going to talk about how I'm going to use them to help me answer a question about finding the perimeter of a rectangle based on what I know about combining like terms. Okay, so if I was given a rectangle and I have a length that's 3x plus 2 and a width that is 5x, remember that perimeter means addition of all of the sides. So in this problem, if this visual was given to me, I would add to the visual and I would write down what the length is based on knowing opposite sides of a rectangle are congruent. That's the way I would make it look. So anytime I'm dealing with perimeter, I would think about addition of all of the sides. So here's what I'm going to write out to find the perimeter. I usually start on the left side of my shape and I go clockwise around it. So I'll plug in 5x plus 3x plus 2. Notice I'm putting that length in parentheses down there. Plus 5x plus this length, which is 3x plus 2. So in order to get that perimeter completely simplified, what I'm going to do is I'm going to go through and identify my like terms. I'm going to circle all my x values and add them together. 5 plus 5 is 10, 3 plus 3 is 6, so that gives me a total of 16x. And then I'm going to put my numerical values together, and that would give me 4. So that's the way I'm going to write my perimeter. My final perimeter is left as an algebraic expression, and I'm okay with that as an algebraic thinker. 16x plus 4. Okay, so that's an idea of perimeter. No matter what the shape is that you're given for perimeter, remember you're going to be adding all of the sides up. Let's compare that to a problem that is dealing with area of geometric shape. So if I have a rectangle and it says, all right, find the area of this one, I know that the area formula for a rectangle is length times the width, so I'm going to use that. I'm even going to go over here to the side, and I'm actually going to start with the width because it's a monomial term. It's just a number. And I'm going to multiply that width times the length. Look at how I'm going to write that out. I'm going to have 5 times 8k plus 3, and I'm going to use a distributive property to multiply that out. Remember how distributive property asks you to take a scalar and multiply it by everything inside of the parentheses where you have an algebraic expression? So actually I can multiply these two numbers together, which gives me 40. I'll write a k down on that. Then 5 plus 3 gives me 15. I bring my plus sign down. So the area of my rectangle in this situation is 40k plus 15. So I do that every time. It doesn't matter if those lengths have a fraction on them, or our numbers up here are variables and or numbers. So it's okay that I leave them as an algebraic expression.